Hello everyone, today we are back with step a day, so this is day 2 and we are going to be doing this question. So this is step 2, question 1 from 2004 paper. Let's just get straight into it with I. So it's saying find all real values of x that satisfy this equation. Okay, so whenever you have these square roots, you want to bring the square roots to one side and the other terms to the other side. So we have square root of 3x squared plus 1 plus the square root of x. We take the minus 2x minus 1 to the other side, so it's 2x plus 1, right? And now we just square both sides to try to get rid of some of the roots, right? So square that. Let's try sort this nasty square root out. 3x squared plus 1 plus root x, and then root 3x squared plus 1 plus root x. So if you time these terms together, it's just going to be itself, because that's just how it is with roots. Times this by this, they all become in one big root. They're times together by each other, so x, and then times by 3x squared plus 1, and there's another one of that, so we write 2 here, and then root x times root x is just x, so plus x, right? And that all equals 2x plus 1 squared, so 2x plus 1, 2x plus 1 is 4x squared plus 2x plus 2x, so plus 4x plus 1. So that's all 4x squared plus 4x plus 1. Now let's try bring these terms to the other side. So we have 2 root x, 3x squared plus 1, all of that equals, so 4x squared, and then take this to the other side, so minus 3x squared is x squared, and then the 1 and the 1, they cancel, so just write them out, and then you take the x to the other side, so 4x minus x is plus 3x, right? Now we can square both sides again, so square this and then square this, so that's 4, and then the square root cancels out. I'll just write it like that, so x 3x squared plus 1 equals x squared plus 3x squared, so let's work out here, x squared plus 3x, x squared plus 3x, so that'd be this times this, which is x to the 4 plus 3x cubed plus 3x cubed, so plus 6x cubed, and then 3x times 3x is 9x squared, so plus 9x squared, right? Now times this by this, so that's 12x cubed, 4x times 1 is plus 4x, and that's all equal to that, right? X cubed plus 9x squared. Now let's take everything to one side, so let's take this to the other side. So 0 equals x to the 4, and then 6x cubed minus 12x cubed is minus 6x cubed, and then the 9x squared, there's nothing to cancel, and then the 4x we take to the other side is minus 4x, right? And you can clearly see we can take out a factor of x, so that becomes x cubed minus 6x squared plus 9x minus 4. Okay, now let me show you a little trick. When you're trying to guess for factor theorem, just look at the last term. One of the roots, it has to be plus or minus 1 perhaps, or plus or minus 2, or plus or minus 4. So you can try all of these combinations, because for example it will be like x minus 1, and then the other root might have to be like x plus 4, for example, right? So it needs to be something that will time together to make minus 4, so it can't be like 5, right? Anyways, so let's try x equals 1. So we have 1 minus 6 plus 9 minus 4, so that's 10 minus 10, which is 0, right? So if x equals 1 works, then x minus 1 is a factor, right? Now let's divide x minus 1 into this equation, 6x squared plus 9x minus 4. X into x cubed is x squared, so it's x cubed minus x squared. Now you take that all away, so it's minus 6x squared minus x squared, so plus x squared, so it's minus 5x squared. Take this down, plus 9x. To get from x to minus 5x squared, you times by minus 5 of x. So, okay, so we have that now. So minus 5x times x is minus 5x squared, and then minus 5x times minus 1 is plus 5x, right? Wait, that's meant to Take them away, you get 4x, bring down minus 4, right? So, okay, so we need to get from x to 4x, so we times by 4, so it's plus 4, right? So, yeah, that's our thing, that's our quadratic factor, so x squared minus 5x plus 4, right? Okay, now let's try factorize this quadratic. So in this set, add times together to make 4, two numbers, a, b for example, and add together to make minus 5. So that's just clearly x minus 1, well, minus 1 and minus 4, right? So this is our final thing. But you see we have a repeated factor of x minus 1, so we can just put that here. So this is our final solution, that all equals 0. So our roots would obviously be x equals 0, 1 and 4 if you set each bracket to 0, okay? But if you have noticed, we have squared it twice, so there is a chance that we have had some dummy equations. For example, consider a simple equation, x equals 2. If you square both sides, right, you get x squared equals 4. Therefore, x equals plus or minus 2. But we clearly know that x is just 2, so that can't be right. So you create dummy solutions. So that's why we need to check. That's the problem with squaring it sometimes. So let's write our equation again. So we have root 3x squared plus 1 plus root x, right, minus 2x minus 1 equals 0. Okay, so now let's sub in all these values and see if it works. So like when it's 0, so it's 0 plus 1, so 1, plus root of 0 is just 0, minus 0, minus 1. Root of 1 is just 1, so that equals 0. So 0 is fine, that's a solution. So we take that. Now x equals 1, so root of 3 times 1 squared is 3, 3 plus 1 is 4, plus root of 1 is 1, minus 2 times 1 is minus 2, minus 1 equals 0. So root of 4 is just 2. So it's 2 plus 1 minus 2 minus 1. So obviously that just cancels out, that's 0. So 1 is also okay. And then let's try 4. So we have 3 times 4 squared. 4 squared is 16. 16 times 3 is 48 plus 1, so that's 49. Plus the root of 4 minus 2 times 4, which is 8 minus 1. So this is 7 plus 2 minus 8 minus 1, which is 9 minus 9, which is 0. So actually, all three of the roots that we had actually worked. So there was no dummy solution this time, but there could be for the next one. So let's just take them, right? Okay, so that's I. Let's go to I. And with step questions, the part I normally helps quite a lot. So let's try to see if we can find any similarities. Alright, so here's the equation. So 3x squared, so it's root 3, it's similar to the first equation. Root 3x squared plus 1 minus 2 root x. And let's just take the term to the other side again. So that's 1 minus x. Right? Okay, so now let's square both sides again. Right? So let's focus on this side first. So root 3x squared plus 1 minus 2 root x times by itself. 3x squared plus 1 minus 2 root x. So this is just itself plus 1. So it's minus 2 times this, minus 2 times this. So it's minus 4 lots of the root of x, 3x squared plus 1. And then minus 2 root x times minus 2 root x is just plus 4x. Okay? And that is expansion. Now we need to expand 1 minus x squared. So 1 minus x is 1 minus x times minus 1. So minus 2x minus x times minus x is plus x squared. So 1 minus 2x plus x squared. Okay. Now actually we see this root now is negative, so we want to take it to that side, and then all these terms to that side, right? So let's do that. So if 3x squared, we're taking the x squared to this side, so it becomes 2x squared. The 1's just cancel out again, and the 4x plus 2x, because we're bringing this minus 2x to the other side. So plus 6x equals 4 root of x 3x squared plus 1, right? But I'm noticing that I feel like this is similar to what we had before. And if we look here, so let's just rub this out to make it neater. If we look here, this is what we had at one point, right? We had this 2 root x, 3x squared plus 1 equals x squared plus 3x, right? But here we have 4, right? And then 2 and 6. So let's just divide by 2. So we get x squared plus 3x equals 2 root x, 3x squared. So this is quite a hard spot, but just noticing like these equations are very, very similar. And in fact, they're identical. So we've already solved this equation, haven't we? Remember, we squared both sides. I'll put it back now. We squared both sides. We got here, we solved for it, and we got these values. But of course, we've also squared this equation, so we need to try out all these values. So x equals 0, 1, and 4, because that's the solutions of the equation. But that doesn't mean it will work in our equation for part II. So let's write it out again. So it's root, and so that equals 0. So now let's sub in each. So let's sub in x equals 0 first and see if it works. So it's root of 3 times 0 plus 1, so just 1, minus 2 times 0 is minus 0, plus 0, minus 1. So root of 1 is just 1, so it's 1 minus 1, right, which is 0. So x equals 0 works. Now let's sub in x equals 1. So we have 3 times 1, which is 3. 3 plus 1 is 4. So root of 4 minus 2 times root of 1 is just minus 2, plus 1 minus 1. So it's 2 minus 2 plus 1 minus 1, right, which is 0. So x equals 1 is also working. So, okay, let's try an x equals 4. So 3 times 4 squared. 4 squared is 16. 16 times 3 is 48. 48 plus 1 is 49. Minus 2 times root of 4, which is 2, so minus 4. Plus 4 minus 1. So that's 7 minus 4 plus 4 minus 1. That cancels, so 6, which is not 0. So we actually found out a dummy solution. So the only solutions are x equals 0 and 1. Okay, let's go on to the last part. So it's root 3x, so the same thing again. 3x squared plus 1 minus 2 root x again. Okay, and let's bring the terms to the other side. So it'd be minus x plus 1 would be x minus 1, right? But I'm already seeing like this is extremely similar already to the equation we just had, right? Just before, because it was 3x squared plus 1 minus 2 root x equals 1 minus x squared, right? So this is the same, but this is, instead of x minus 1, it's 1 minus x. But if you think about it, when you square both sides, we already worked this out, right? And then you square this side. But when you square that side, you get x squared minus 2x plus 1, which is exactly the same thing that you got here. So actually, this equation is literally the same as part II. There's no difference, because when you square it, the sign doesn't matter. 1 minus x squared is the same thing as x minus 1 squared, right? So honestly, you don't even have to do any work. You can just say that it's the same equation. Same equation. And straight away, you can just solve it. So let's bring back everything to the other side. Because remember, this equation links to II, and then, which is this, right? It simplifies to that. And then, which we already worked out here. So they all link. I links to II, which links to I. Okay, so minus 2 root x minus x plus 1, right? Now let's sub in our x equals 0, 1, and 4, because you have to include all the solutions from the first one. So it's 3 times 0 squared, plus 1. So root of 1 minus 2 times 0, so minus 0 plus 1. So actually it gives you 1 plus 1, which is 2. So x equals 0 is actually not a solution. Alright, so we reject that. Wrong. X equals 1. So 3 times 1 squared is 3. 3 plus 1 is 4. Minus 2 times root of 1 is minus 2. Minus 1 plus 1. So it's 2 minus 2 minus 1 plus 1. That cancels 0. So x equals 1 is a solution, right? Now let's try find what x equals 4. So we have 3 times 4 squared. So 4 squared is 16. 16 times 3 is 48 plus 1 is 49. 49 minus 2 times root of 4, which is 2. So minus 4. And then minus 4 plus 1. So that's 7 minus 8 plus 1. So 7 plus 1 is 8, minus 8 is 0. So 4 is a solution. So, yeah. So now we just do our closing statement. Therefore, x equals 1, x equals 4 is a solution. And then you can also say x is not equal to 0. And then here, what could we have said? X is not equal to 4. And then here, all of them worked. So x equals 0, 1, and 4. Right, that's the end of the question. Thank you for listening. Have a good day.